Hi, this is Alex from devstories.eu. GitHub Actions, Episode 6 of 14. You set up a multi-job workflow, and to make sure the second job has everything it needs, you bundle up your entire dependencies folder and pass it along. But suddenly, your build takes 5 minutes longer and your storage usage hits the roof. The problem is a fundamental mix-up between two distinct data mechanisms, and that is exactly what this episode covers: optimizing data, caching versus artifacts. We will clear up the confusion right away. Caching and artifacts both move files around your GitHub Actions runners, but they solve entirely different problems. Think of artifacts as what your workflow produces. Think of caching as what your workflow consumes. If you swap these roles, you will silently bottleneck your entire pipeline. Artifacts are generated files that you want to keep after a job finishes. This could be a compiled binary, a test coverage report, or a zipped archive of your final build directory. They exist for two primary reasons. First, to let you download the final output of your workflow once it completes. Second, to pass generated data between different jobs within the exact same workflow run. Because each job runs on a fresh virtual machine, any files created in job 1 are instantly lost when that job ends, unless you explicitly upload them. By using the upload artifact action, you save those files to GitHub storage. Then, job 2 uses the download artifact action to pull them into its own clean workspace. Now, compare that to dependency caching. Caching is purely a performance optimization designed to speed up your workflow across different runs over time. When you build software, you usually download thousands of third-party dependencies, like packages from npm or pip. Fetching these over the network on every single run is slow. Instead of downloading fresh dependencies every time, the cache action saves your downloaded dependency folder on the cache servers. It assigns this cache a unique key, almost always based on the hash of your lock file. On tomorrow's workflow run, GitHub checks if the lock file matches an existing key. If it does, it restores the folder directly into your runner in seconds, bypassing the package registry entirely. Here's the key insight. The biggest mistake you can make is using the upload artifact action to move a massive dependency folder, like node modules, between jobs. Artifacts process data by zipping it, uploading it, downloading it, and unzipping it. Doing this with tens of thousands of tiny text files adds massive network latency to your runtime and eats into your account storage quotas. Artifacts are not built for raw speed. They're built for safe data transfer and permanent record keeping. Caches, on the other hand, are highly optimized to pull heavy dependency trees quickly, and they automatically age out and delete themselves to save space. Picture a proper pipeline that uses both correctly. You have a workflow with a build job and a deploy job. In the build job, your first step uses the cache action to instantly restore your npm dependencies from yesterday's run. Your code compiles quickly, producing a final application binary. You then use the upload artifact action to save just that single binary file. The build job ends and the runner is destroyed. The deploy job spins up on a new runner. It does not need the cache and it does not need the npm dependencies. It just uses the download artifact action to grab the compiled binary you've just built and then pushes it to your production server. Caching is a disposable shortcut for things you download, while artifacts are the essential handoff for things you create. Thanks for hanging out. Hope you picked up something new.